Hello everyone, and welcome to day 11 of solving LeetCode problems until I'm hired by a FAANG company. Today we're going to be solving 2058, find the minimum and maximum number of nodes between critical points. A critical point in a linked list is defined as either a local maxima or a local minimum. A node is a local maxima if the current node has a value strictly greater than the previous node and the next node. A node is a local minima if the current node has a value strictly smaller than the previous node and the next node. Note that a node can only be a local maxima minima if there exists both a previous node and a next node, obviously. Given a linked list head, return an array of length 2 containing min distance and max distance, where min distance is the minimum distance between any two distinct critical points, and max distance is the maximum distance between any two distinct critical points. If there are fewer than two critical points, return -1 and -1. So example 1 here we have 3 and 1, since this is obviously going to be, we're going to return -1 and -1. There are no critical points. We have 5, 3, and 1. This wouldn't really be. This would be a local minimum because both of the left and right are higher. This would be a local maxima. And also 1 here would be another local minimum because 5 is greater and 2 is also greater. Example 3 real quick. There are two critical points. We have 1, 3 over here, right, is greater than both left. Then we also have the fifth node. It's also greater. Okay, so really, I also believe this type of problem is pretty straightforward if I'm not mistaken, right? Like if we have all of these nodes, right, and we're just going to be going through the linked list, we could actually here just have a simple array in which we're going to be appending the position at which we have found a local maxima or local minimum, right? So here, for example, since we have 3 critical points, which one is at the 0, 1 second position, right? Like once we have all of the local maxima or minimum positions, we can simply just start iterating and get, well, the maximum is always going to be the difference between the last and first element. So like the end of the array would simply be 6 minus 2 equals 4. But actually, yeah, this is actually not the 5th position. This is the 4th. And this is the 5th position, or again, like the 5th index. Well, once we have this, we can just get, right, the difference. 5 minus 2 is 3. So the maximum distance is going to be 3. And then we can just go through array. The minimum would be 1. And we would return indeed. Probably here the complicated part would be to distinguish if we are at a local maxima or local minimum. But really not that much. Like once we start at an index, we would just really go to the next one and start comparing left and right. So yeah, I actually believe we could start coding something like this up. I'm just going to go ahead here real quick and start seeing, right? We could have here previous node is going to be equal to null. Right now it would just be making actually the code. So I believe that's what we should be doing right now. So we're going to go ahead and create the array that we're going to return. Class equals this. We're going to be iterating through head. So for head, of course, here we're just going to be do head equals head.next. As I mentioned previously, the while loop is actually going to be head.next, right? Just to be clear. So head is going to be like the current node. We're going to need a previous node. It's going to be none at the beginning, or actually is going to be equal to head, right? Then head is going to be equal to head.next, right? The second element. And now we can start comparing. Here we're going to check. So if head.val is greater than previous node.val, and also head.val is greater than the next one. Next one, we're simply just going to call it here next. Node is going to be equal to head.next. So next node.val. We need our special array where we save all of the indices, in which we're going to append r.append. We're going to append the index, which in this case is going to be I. I is again going to be one of our values here. And every time we start iterating, it is indeed going to be, we're going to add 1 to I. Of course, if head.val is less than previous node.val and head.val is also less than next node.val, we're also going to append it. And just looking at this, we could actually just make a single statement just so that we don't really repeat any code. So we can delete this elif now, right? And well, once this has happened, we can simply also do, so previous node is now going to be equal to the current one, which is head. Now we're going to do I plus equal 1 and head equals head.next. And well, once we have iterated through all of the linked lists, we can simply do here. So if the length of array is less than 2, well, we should return the -1 and -1 case. And else, well, we need to get the minimum and maximum. So here, max distance is actually just going to be array at -1 minus array at 0. Right, doing actually -1, it's not really the best approach. I believe we could even just use I-1 if I'm correct. And for min distance, we should indeed iterate through our array. So for I, in range of length of array, but we're actually going to start at 1 so that we can compare with the previous one. We're going to first assign min distance to a very large value. So it could be float.inf. And here we could simply do, so min distance is equal to min between r at I minus r at I-1, or min distance. And once we have this, we would simply return min distance and max distance. And I actually believe this should be it. Let me just go probably through this example and see if it would actually work. And actually, yeah, we cannot do I here, I-1. We do need the length of array, so I'm actually just going to do n equals length of r. And here we would actually do n-1, right? Minus, of course, we could also calculate the length of the array just right here, n equals n plus equal 1, where n is equal to 0. This would just make it a little bit more efficient probably, but not that much. So n-1. And yeah, I actually believe this should be it. So, well, let's see what happens if we run this. Okay, so we have 2 test cases that didn't pass. Our output was -1 and -1. Oh, this is an OR actually. Oh my god, how did I miss that? So this was an OR all along, of course. Unfortunately, I just mistyped it into an AND. So now if we run this should start working much better. Okay, so 3 test cases have been accepted, right? And well, let's see what happens if we run this now. Okay, so there it is. We have now successfully done the 11th day. This algorithm beats around 50% of users using Python. Memory-wise, 30%. Probably not as efficient regarding memory. The time complexity is basically O(n). It's really not bad at all. Probably could be a little bit more readable, but actually I'm just very happy with this solution.